Data science is such a vast field of study. And for a beginner breaking into data science, it might seem a bit confusing, particularly because there are so many topics to learn about and to master. And the big question is, which one is suitable for each and every learner? And the question very much depends on the unique objectives of each individual learners, because everyone will want to use data science in a different way, perhaps analyzing different types of data, whether it be images, tabular data, audio, streaming data. And so I think I might have the solution for this particular issue. And so when Pack Publisher reached out to sponsor this video and also provided a copy of this particular book, I thought it would be a great opportunity to show you how you could repurpose some of the contents and codes that are provided in a book similar to this one, and that you could use it for repurposing your own data science projects. And so why reinvent the wheel when you already have a wheel prototype, which you could adjust to your own specific liking and also to your own unique project requirements? And so in this particular video, we're going to focus on feature selection, and I'm going to take you on a walkthrough and also show you how to practically take some of the contents and codes that are presented in chapter 4 and then repurpose it so that you could use it to your own real-world data science project. And so without further ado, we're starting right now. And so before beginning, let's take a quick look at the book. So the Machine Learning with PyTorch and Scikit-Learn, as the name implies, will show you how to use Scikit-Learn to perform machine learning tasks, PyTorch for deep learning tasks. And so at a high level, the book will span a total of 741 pages of content, and it will span over 19 chapters. So let's have a look at it. So in chapter 1, you're going to learn how computers learn from data, and it's going to provide you with the basic terminology and also a roadmap for building a machine learning system. It will briefly go through how you can set up Python for your machine learning environment. And then in chapter 2, it will take a brief look at some of the basic learning algorithms for classification. In chapter 3, it will take a look at some of the machine learning algorithms or classifiers that are used in Scikit-Learn. Then it goes to show you how you could build machine learning models using Scikit-Learn via logistic regression, support vector machine, and also using some other kernels in support vector machine. Also, how to build a decision tree, and also variants such as the random forest. It will also cover about k-nearest neighbors as well. And then in chapter 4, which we're going to focus in this particular video, it covers some of the important topics of data handling. And this includes how to deal with missing data, how to handle categorical data, because in Scikit-Learn, it typically will use numerical values for building up the machine learning model, but then your data might contain categorical data, such as low, medium, high for your class label, or the various colors like red, green, blue, which could be mapped into ordinal or nominal features. It's also going to cover about how to partition dataset when you split it into the training and the testing. Well, chapter 5 covers the use of principal component analysis for reducing the dimension of the data. Chapter 6 will cover about how to model evaluate and how to perform parameter optimization. Chapter 7 will take a look at ensemble learning, where you're going to combine the powers of several learners into one meta learner. Chapter 8 shows you how to perform sentiment analysis, and you're going to use the IMDb movie data. In chapter 9, you're going to learn about regression, and some of the data set that are used are the Ames housing data set and some other algorithms that are used for regression as well. Chapter 10 covers clustering analysis. Chapter 11 is building up artificial neural network models. And then in chapter 12, you're going to learn about PyTorch and how to use it for various deep learning tasks. Chapter 13 goes into much deeper details. Chapter 14 shows you how to use a deep convolutional neural network for classifying images, how you could use recurrent neural networks for modeling sequential data. Chapter 16 will be on Transformer for natural language processing. And in Chapter 17, you're going to be performing generative adversarial network for synthesizing new data. And so in a nutshell, this allows you to learn from the data. For example, if your data is on t-shirts, then it will learn from it, and then it will synthesize new t-shirts based on the data that it has learned. Chapter 18 will be on graph neural net. Chapter 19 will be on reinforcement learning. And so all of this will be covered in more than 740 pages of content. And so let's jump to Chapter 4. Chapter 4 is on page 105. Okay, so I'm going to leave all of this reading to you, and we're going to jump over to the code. All right, so let's minimize this a bit, hide the sidebar, and then I'm going to spin up a Colab notebook, which you could do as well. And then we could say practice chapter 4. A point to note is that the book also comes with the GitHub repo for codes of this book. And so for simplicity, I'm going to just hard code the code from the ebook here into this Colab notebook. Okay, and so let's begin. Let's just copy and paste some of the contents here from IO, import, string, IO. In the meantime, I'll just hit on connect. Okay, and then we're going to hard code the contents here. So you notice that it'll have some missing data. So we have this 3 quotations so that we could have the contents spanning multiple lines. We're just gonna skip the comments here. And so why don't we pretty much do this first? So we're creating a text file and we're assigning the contents to CSV data. And the text file will be essentially a comma separated value file, which is a CSV. And then in the next step, we're going to take the CSV data here as an input to the pandas read CSV function in order to create a data frame. To do that, df, so we're creating a variable to store the data frame, and we're using the read CSV function to read the contents of the CSV data. And then we're going to use the string IO to encapsulate that. And then let's run df so that we see the contents. And there you go. This is the contents of the data frame. So you're going to notice here that there are some missing values here. And then in this particular block of code, we're going to do a summation of the missing values. So let's do that. Let's run this first. Let's see what happens. Okay, so apparently if we have an empty space, it doesn't detect it as a missing value. Well, so we'll do it like this first. Okay, there you go. So now we could see that in row 1 with the index number of 1, because Python counts starting from 0. So row index 1 will have a value of true because it is a missing value, because the function here tests whether each individual values here are missing, yes or no. And if it is missing, then it'll be true. And if we add the sum to it, we're going to get the summation of the missing value for each column. So here we see that in column C and D, there are 1 and 1 missing values. Go here, df.values. So if you do that, then it'll convert it to a data array. Oh, okay. Should we import NumPy? Oh, okay. Take away the parenthesis. All right, there you go. So we have the array. So when you're going through the code, it would be nice to also comment your code, not just have a blank notebook like this. And so for those who are breaking into data science or using pandas for the first time, and it might seem difficult, then it is highly recommended that you also kind of like write notes into your Jupyter notebook. So here it says identifying missing values in tabular data. So we could do that. We could document that. We add it here. Click on the text cell, and then you could double click on it. Click on the toggle heading. Click on bold, and then you could type in the contents here. Identifying missing value in tabular data. So I like to make it 3 hashtag here, or hash symbol, and then we're going to add another one on top, make it 1 hash symbol, and then we're just going to say, okay, chapter 4. And then you could essentially type in some of the notes that you are taking when you're reading this book, because when you're taking notes, you're internalizing the contents to be your own, and that will help you to digest the contents much better. For example, you could create something like this. Here, we're going to import, or here we're going to create a CSV data file. Now let's create a pandas data frame from the CSV data. And then I like to use the tick symbol so that it becomes highlighted like that. It's slightly highlighted and the font will be a bit different so that it distinguishes itself from the other content. And make note that you could also use Markdown. For example, I could use here in italic, and this data frame is in italic. CSV data is using the tick symbols. And then we're going to say create a CSV data file and assigning it to the CSV data variable. Right, okay. And then here we're going to say let's check the number of missing values in the data frame. We can also convert data frame into a NumPy array. And then we could say using the .value method on the df variable. See, so when you're writing all of this content out, it helps you to evaluate what's the purpose of each and individual method, or what's the name of the variable, or what's the output look like, and what's the type of the output. So this will help you to internalize the contents as you go through the contents of this particular chapter, right? And when you're structuring your notes, you could make use of the headings and subheadings that the book has, like this one. We could create a new one, new subheading. You could bold, paste the contents in, and then proceed to the next code cell. So what does it do? When you run it, what does it do? When you compare it with the df data frame, which looks like this, and when you apply the drop any function, what does it do? You see that rows with the index 1 is deleted, rows with index number 2 is deleted, and the only remaining is the one with index 0. And so the drop any function will drop all rows that contain at least one missing value. So if it has a missing value of at least 1 in the row, it will be dropped. And notice here that the input argument is axis equals to 0. And so that will mean that you want to apply this particular drop any function on the row, because the rows corresponds to the axis equal 0. But if you say axis equals to 1, let's do that. What do you notice? You'll notice that the columns will be deleted. So any columns that have at least one missing value, it will be deleted. And so therefore columns C and D were deleted here. So only columns A and B will be kept because it contains no missing data, right? And then you could take notes here. You could say here we're going to drop any rows, and then you could say axis equals 0 via the drop NA method or function, and then you could copy that contents, paste it here, modify a bit, drop any columns, right? And therefore you have a complete note. You could say let's start by seeing the contents of the df variable. Again, the data frame stored in the df variable again, right? Okay, so I'm going to skip most of the contents here because we're going to focus on the feature selection. And so let's have a look here. So here they're explaining about the API for Scikit-Learn, particularly the estimator API. And so the functions or the estimator, for example, if you're training a model, you could create a variable called est for estimator, and the estimator variable could contain the name of the machine learning function, for example, random forest. And then what you could do here is that you could essentially fit the model on the X-train and Y-train data. So the estimator here in our case will be the machine learning algorithm. For example, we typically can name it model, or some tutorials will name it CLF for classifier, while I like to name it as model for generic usage, which could then be replaced with input arguments indicating the use of other learning algorithms. Let's say I might change it from a random forest to a k-nearest neighbor and then to a logistic regression. And so I could keep the name of model variable intact. Or in other cases, you could also name the variable to be an acronym of the machine learning algorithm. Like for random forest, you could name it RF. For support vector machine, you could name it SVM. For linear regression, you could name it LR. Okay, so the fit function here will allow you to train a machine learning algorithm. and that will result in the building of a machine learning model. And there are other transform functions that will allow you to transform the data set. For example, if you want to transform the training data or the test data. So here are some of the steps that you could do, and it summarizes this in a schematic way. For example, you could use the training data, and then you use the fit function, and then you use the transform function. And once you use the fit function here, you have already trained a model for performing transformation of the data. And then you could apply this model on a test data because you have already trained it using the fit function. And then the model could be used to transform the test data into a transformed version. Okay, so this is the schematic illustration of the concepts of the estimator in Scikit-Learn. So let's have a look at how to handle categorical data. And because this is a heading and these are subheadings, we're going to modify this a bit. You could also add numbers to it as well. You could call it 4.1 for section 4.1. And then if you have anything underneath it, like a subheading, you could call it 4.1.1, which will allow you to easily navigate the contents here. You could call this 4.2. And now handling categorical data could be 4.3. Did we add a dot? Yeah, we did. And then handling categorical data, and we could just have it as a bold text. 4.1, and then we could say categorical data encoding with pandas. Make it bold, and then we're just gonna copy the code here. So when you're starting out the tutorial, it's always nice to just hand code the content. And whenever you encounter an error, it might be due to some mistyping. And take a look at the error. And when you have a familiar idea of which type of error creates which type of syntax that you will see, then over time, whenever you encounter a similar syntax output, then you'll know that what went wrong and you'll know how to correct it. Let's continue typing. We're typing the contents of this data frame. And notice that whenever we use quotation mark, it will be a string as the data type. And each list here, each of this is called like a Python list. Each list will be a single row. Okay, let's have a look at the contents first. So what we have just done was create the contents of this particular data frame, and then you'll notice that the column names are the index number of the column location. And you're going to notice that we're going to assign the unique column names in the next line of code. Let's do it. So we're using the dot columns function on the df variable so that we could rename the index number 0, 1, 2, 3 to the respective column label, class label. Let's have a look at the contents again. And now you see that the column name has been relabeled. Can label the column names using the dot column function and assigning a corresponding list, Python list, or corresponding list of column name. Here we create a data frame. And let's have a look here. Mapping ordinal features, right? So let's create it. Create a new text cell, and then we'll use like this for 0.3.2. Make it bold. Mapping ordinal features. So ordinal features will have a respective order, meaning that large is bigger than medium, extra large is bigger than large, and mediums. Do that. Size mapping equals, and then we're going to create a dictionary using the braces here, XL, and then we're going to use the colon, which will be mapped to the number 3. And the second value here is L, or large, which will be mapped to 2. M be mapped to 1. Let's have a look at it. Size mapping. Okay, so this is a dictionary, and then we're going to apply it here. df size. Before doing that, what this will essentially do is it will select the size column, which is here, and you're going to see the contents, which is M, L, XL. And then we're going to apply the map function here in order to map the values from L to be 2, from M to be 1, from XL to be 3. So let's do that first. Let's say map, and then the contents of the size mapping variable, which is the dictionary here. And then mapping was performed. But then what we want to do next is that we want to replace the contents of the columns here by the mapped values. So we could do df size and then equal, so that we will assign the new mapping values to the df size column, which will overwrite the prior content. So MLXL will be overwritten by 1, 2, 3. Let's do it, run it, and then have a look at the contents of df again. And you'll notice that the content has been replaced to be 1, 2, 3 from MLXL. Okay, and now we're going to work on the encoding class label. So that will be 4.3.3. We'll make it bold. 4.3.3 encoding class labels. As I mentioned already, it's nice to type in each line of code manually. So that will help you to reinforce the contents here. And we're going to create a variable called class mapping. And then we're going to do this label idx, which is essentially like this: label colon and then the value. So we have the key of the dictionary and the value, the key and the value. For, because we're going to do a for loop of this idx label in enumerate. It could be like this, or you could hit on enter as well to go to a new line because code is quite long. And then np unique, and then df, and then class label. And it's a good thing that Jupyter Notebook created automatically corresponding closing syntax. And now we're going to have a look at class mapping. And then let's have a look at the error. df class labels. Oh, okay. I think I typed in this wrong. Should be class label. All right, and now it works. So you see that class 1 corresponds or mapped to value of 0. Class 2 will be mapped to a value of 1. And then we could repurpose this code as mentioned here as well. So we're going to change size to class label and change size to class label, and it's going to be class mapping, enter. And now you're going to have the class label to be mapped to the values of 1 and 0. Okay. And then the next part here, it will show you how you could reverse from 101 to become class 2, class 1, class 2. So you could do that by using this block of line of code here. So let's annotate this a bit. Encoding class label. So we're going to reverse the mapping of values back to their original categorical labels. And let's create a INV or inverse class mapping. Create a dictionary value k for key k underscore v in class mapping dot items. So yeah, we could also use the same names here as well. Instead of v, we could call it idx. And then instead of k, we could call it label. To make this inverse work, let's do this label, and then we're going to replace it with the contents here, class label dot map, and then we're going to use the inverse class map, and then we're going to print out the contents of the data frame. Oh, syntax error, see what's misspelled. df label, try the network class df. Oh, okay, I have to close the brace here. There you go. Okay, label. So I think, and now I should work. Print out the contents of the data frame. All right. Oh, I have to do this again. Yeah, I might need to run this all over again because it was probably overwritten. I have to run the code again from creating the data, doing the mapping, generating the class label, and this should be 101. Okay, and then let's do this. All right, and so we have reversed from 101 back to its original label right here. Okay. And now it's going to do the same. Okay, so here it shows how to use the label encoder to transform class 2, class 1, class 2 to the array of 101 without using mapping. So instead of using mapping, you could use the label encoder. Okay, so you could try that out and I'll leave that out to you. And here it's going to do some one-hot encoding on the nominal features. So nominal features will be green, red, blue. So this one has no ordering. So green, red, and blue will be quite same in terms of the important color. Not similar to how large is larger than medium or XL is larger than L and medium. All right, so let's see how they do it. All right, so let's continue. We're going to do the one-hot encoding. So create a text. variable x, color, size, price, dot values. Let's see what is in here. All right, so we have just created an array of the contents of the data frame of the first 3 columns, color, size, price, without the class label. And now let's do this. Create a transformer using the label encoder. Label encoder. Would that work? So we first have to define it. Okay, we skipped that. So let's copy that here. Does it work? It should work. And now we're going to type X. We're going to select all contents of the rows, only the first column. Only the first column, column 0, green, red, blue. It says here, green, red, blue. So all rows specified by the colon here. 0 is the column with the index number 0. And now we're going to replace it with the transformed value. Fit, transform, and then the content of first column and replacing it. Okay. I think we have too many closing bracket or not. Oh, okay, I think. Let's put that here. Oh, okay, I have to take that out. Okay, it works now. Let's have a look at X. Okay, we'll put X here. And it looks 1, 2, 0, 1, 2, 3, 10.1, 13.5, 15.3. Okay, it looks the same. So here we have just replaced green, red, blue to 1 to 1, 2, 3. Okay, so this is one way of doing it, and then we have the one hot encoder way of doing it, and then we have the column transformer way of doing it. Okay, so I'll leave that up to you, and we could also use get dummies to perform the one hot encoding. So in one hot encoding, essentially, so instead of replacing the colors with the numbers of 0, 1, 2, it will create a new column for it. For example, if the column here is called color, it will create a new column called color green. And if the color is green, it will have a value of 1, like here. And if it's any other color, it will have a value of 0. Okay, so I'll leave that up to you guys to perform. And then let's jump over to the other parts. All right, so here it's going to read in the wine data, and then it's going to do some training and test data splits. All right, and then it's going to perform some scaling of the data. And so the fun part that I want to highlight in this tutorial is doing the feature selection. Okay, so we're going to use this wine data. Get the data, go to here. That should be the data. Okay, and it downloaded the data. So create a new heading here. Let's call it partition. Let's name it the same as the book. Okay, we should use 3 hash symbols, and then we're loading the data in pandas as PD, and then we're going to say df equals to PD read CSV, and then the function v, and then we're going to have a look at the content. All right, and it says here to be header none. Let's do that. Header equals none. We don't want the header. All right, and then if there are labels here, copy that, and then we're going to reformat this. Let's see if it runs. It's okay because we call it df. Yeah, let's call it df wine. And then we're going to rename the columns. All right. Oh, okay. Let's see what happens. Maybe it's the syntax. Let me add that up here. Let's do it again. Oh, we've typed in the wrong data frame. Okay, now it works. So now the data frame has the columns relabeled, and it looks like the one in the book. And here it's going to do the data split. And so it's going to select the X and the Y data. So this part is the X, this part is the Y. So let's do it. So we could say load the wine data from the UC Irvine machine learning repo. Relabel the column names. And then we're going to perform the actual data splitting. So we're going to use the function here. But then we could do it like this, which might be easy to read, or we could put it on the same line as well. Let me show you both ways. Dot values X. So we'll look at X. So that is the value starting from. So we're going to select all rows because we used the colon here. So all rows will be used. And then we're going to select starting from column index number 1. So we're going to skip the class label. It is index number 0. And then we're going to go with index number 1, which is starting from the second column, because we're going to get the data excluding the class label, because the class label will be the Y variable. So for the X, we're going to use from alcohol until the end here. That is why we're using 1 colon. So starting from first here to the last. So this is the second column until the last. And let's do Y. Y is equal here. Right? Let's print it out. Here, 1, 1, 2, 2, 3, 3, which is the first column here. 1, 1, 2, 2, 2, 3. And as I mentioned, the example here includes both on the same line. So you could do it like this as well. X, Y. And then we're going to print it separately. Let's have a look here. X, Y. Okay. So we print X first and then we print Y. Okay. And then let's continue with the actual data splitting. So actually the actual will be the next step. So here we're going to do the separate X and Y from the F. And then we're going to use this to paste here, which is where the actual data splitting is occurring. And let's type it, X train, X test, Y train, Y test equals to train test splits, X comma Y, test size equal to 0.3, random state is specified to be 0, and then stratify is specified to be yes. X train, X test, Y train, Y test Okay, so all of it is printed out here. Xtrain, Xtest, and then we have Ytrain and the Ytest arrays. All right, and so that concludes all of the contents for the data handling. All right, and so let's continue. So here we're going to perform feature scaling. So for consistency, we're going to keep the name according to the one in the book chapter. So we're going to import min-max scalar. So we're using the normalization approach where each value will be subtracted by the minimum value of the column divided by the range, which is the maximum value of a column minus the minimum value of a column. Let's import it. Xtrain normalize MMS fit transform Xtrain Xtest normalize MMS transform Xtest. So remember that we create a model using the fit transform on the training set, and once the model is built, we're going to apply the model MMS.transform and then using as input argument the Xtest data. Let's run it. And let's print out the contents of the normalized data. And you're going to notice that it'll be in the range of 0 and 1. So we could actually display it in a data frame if you like. We could say PD data frame and then Xtrain norm dot describe. Let's see what happens here. And then you're going to see that all have a maximum value of 1 and all have a minimum value of 0. So they will be normalized column wise, okay, according to this equation. Let's proceed further. And another approach is to perform standardization using the standard scalar function. So we're gonna skip this and let's go ahead and use the min-max standard scalar. So here we're going to perform min-max normalization. And then we're going to perform standardization. So according to the equation here, the standardization will perform by using the value minus the mean divided by the standard deviation for each column. So therefore, the resulting mean value will become 0 and the resulting standard deviation will become 1. So let's run this, copy it, stdsc, standard, scalar, xtrain, std equals stdsc dot fit transform, xtrain, xtest, std equals stdsc dot transform xtest. And so let's do the same. Let's have a look at the data frame xtrain std, and I'm going to describe it so that I get the min and the max. And so you're going to see here that the mean will become essentially 0 because 6.89 times 10 to the minus 15 would mean that there are several zeros, like 0. And then 15, 0, 689. So it's essentially 0. And the standard deviation is approximately 1, and that is the standardized value. Let's continue. All right, and so here are the approaches for performing feature selection by selecting important features. Because when we build machine learning models, we want to be able to extract the important features from the vast number of initial features to start with. So I'm going to skip the logistic regression part here. So you could go ahead and continue to implement this and take notes as well. As in any other linear regression or multiple linear regression, you're going to notice that there's the regression coefficient, which is provided here in the coef function, and then the intercept of the y-axis is provided here. And there are 3 values because this is a multi-class problem. So there are classes 1, class 2, class 3. And so the intercept here corresponds to the classification of class 1 versus classes 2 and 3, the classification of class 2 versus 1 and 3, and also class 3 versus the other classes 1 and 2. And the same, there's going to be 3 lists for the regression coefficient corresponding to each of the 3 classifications of the multi-class. And then let's see. Okay, there's the optimization of the C parameter, and then looking at the coefficient. So you see that the higher the value, more dispersed value are observed. All right, so I want to show you this part, the sequential feature selection algorithm. So this is implemented by the authors, and okay, let me see if I could go to the GitHub of the book. Let me first find the link. Chapter 4. And this, they actually have the Jupyter notebook. Okay, so they placed it. Let's have a look at the notebook. Okay, so you can see that all contents are already in here. Okay. All right, so let me copy this. Let's copy that. And then we're gonna replace it here. And let's see if this works. All right, it worked. So as a fail proof, you could go to the GitHub and copy paste the code. Like here, you could just copy and paste it in. Let me delete this. That was the data. And we could just delete this. And then we could say this is for this is the sequential, what's it, backward. It's the sequential feature selection algorithm that the authors have implemented. And then we're going to run the code. So here we apply the SBS feature selection. And let's run it. All right, and you got the plot here. So you could also go ahead and try these other code cells that will dive deeper into the feature selection aspect of this. And so in a nutshell, this plot will show you the accuracy on the y-axis, and on the x-axis, you're going to see the various number of features that are used for the model building. So it will sequentially take away a feature and then build the model and see how much accuracy the model produces. So we can see here that beyond 3, the model did not improve. Of course, because the accuracy was already at 100%. And so 3 features seem to be optimal for building a robust model here. Even at 2, you could see a very good accuracy score here. And so accuracy is only one way of evaluating the model, and there are others like the Matthews correlation coefficient. And so you could play around with this code. You could modify this to other metrics as well. But then the score here was using or computed via the calculate score function. So let's continue. Let's have a look here. Assessing feature importance with random forest. Let's create it here. Let's move it down. 1, 2, 3, bold. Assessing feature importance with random forest. Okay, so I'll just go ahead and copy the code. So actually we could break down the code into chunks that are comprehensible. We could say that we're going to build a random forest model. We could just make it bold. Feature labels can go here because it's not yet used there. It's because it's used here in the for loop. And then we're using matplotlib to make the plot right here. Okay, so I guess we have to run this first. Okay, we have trained the model, and then we're gonna make the plot. And so before making the plot, we printed out the values. So these are the ordered values from highest to lowest. Here, from highest to lowest. So the important features are from the left side to the right side. So the higher the magnitude, the more important the feature is to the model. And so this one will select the top 5. Okay, so we could go ahead and copy this. Select the top 5 features. And it's using the select from model, and it's going to select the top 5 from the forest model, which was built previously. And we're iterating through to print out the top 5 features here. And as can also be seen here, they are the top 5 bars from proline to alcohol. From proline to alcohol. And so you could feel free to use these top 5 features in a second round of model building, meaning that in the second round, you would build another set of machine learning models using the top features selected from the initial first model built using random forest. And so these top 5 features could then be used by the second model to build the second machine learning model. So this concludes chapter 4. And all of the contents in the book are quite easy to follow. And you could just skim through the explanation if you choose to understand what they are about. Or you could just skim through the book and jump around, implement the code, and then learn from the error as you type or mistype the code and try to see how to correct the error, as I have already shown you. Sometimes we haven't run a prior cell and it gives us an error output, and therefore we have to run it first. Or maybe we might be misspelling some variable names and it could not detect it because it doesn't exist. And so all of this nuances will allow you to become familiar with the various code and syntaxes as well as the errors that might occur. And so even if you encounter errors, that is a great thing, because if you are able to overcome it, then it means that the next time around, it won't be a challenge for you. And the next time around would be a lot easier. And so this chapter covers about feature selection and also data handling. And there are a total of 19 chapters, as I have already mentioned. And you could feel free to skim through chapters that you are already familiar with and just go to the topics that interest you. And even better is that if you have a data set of your choice, let me show you. Let's say that I go to github.com/dataprofessor. And I'm going to go to the data. So I'm going to show you how we could just repurpose this for another data set. So we have the Delani solubility. Let me click here. Okay, so they are a solubility data set for molecules. So there are a total of 4 input features, and they correspond to the molecular properties of molecules. And the goal is to perform regression to predict the log S value or the solubility value. So why don't I just copy the data link here, and then we could just go to the top here, find the wine data set, and then we could just replace the link with our corresponding data. So let me just create another section. I'll call it solubility data set. So let me go up. I think it might be better that I just create another notebook and then I'll open it side by side. Or like that. Okay, and then I just paste the respective components there. Okay, so I'll call this the solubility data set. So we're gonna typically start by loading in the data set. So we're gonna import pandas as PD. Let me find the respective code cell. Okay, right here. It's right here. And then I could just call it df equals to PD read CSV, and then the link to the data. df, so that I know the contents of the data. And the data already comes with the name of the columns because we have it on the first row right here. And so they are presented here. Let's see, so we don't have to relabel the column names. And now we're going to separate the X and the Y from the df here. So we could just copy this, we paste it here, and then we will do some modifications. So the name of the data frame here is df. So I'm going to modify that to df. This one to df, okay? And where is our x values and our y values? So our y value will be the last column right here. And our x value will be the first column until the column next to the last. So in order to make sure that we're selecting the columns properly, I like to do this. I just copy this. This was from the prior example. So we want to start from the first column. So we just, delete the numbers. And we want to have as the x variable, molog p, mo weight, non-rotatable bonds, and aromatic proportion. So let's see if this works. Right here, first 4 columns. So that works. So -1 would mean the last column. So this is implying that we already have 0 to the left. So it's going to give you the same result. So we want from column with index number of 0 until the last column, which is -1, which we are not selecting. -1 will be the log S column. So we're not selecting that. So we could just delete 0 here. It's the same thing. And then I'll replace it here. And then we're going to select the last column. It should be -1. So let me show you. This should be -1 because it is the last column, the log S right here, log S. So let me delete that. This is correct. So I'm going to change this to -1, and then we have it here. So we're going to have XY, and then we're going to create the X and the Y. Run it. So here we could just say load data. Let me delete this. This is 3. Okay. How about we do like this? 1, 2, 3. Data processing. Let's call it data pre-processing. So here we're going to separate X and Y from DF, or we could just bold it as well. And then we're going to perform the data split. Data split. Oops. Split, bold. And then we're going to copy this, paste it here. Make sure X and Y test size, we can modify it to 0.2. Stratify, we don't need to stratify by Y because it is the regression. So we're going to delete this line. Random state of 0. Okay, let's check to see that data exists. Okay, it exists. We could just scroll down a bit. Okay. And now for feature scaling, we could just say feature scaling. Say that we're not going to do normalization, but we're just going to do standardization. We're just going to copy the code here. And we're going to say we're going to scale the features via standardization. Let's run it. And let's make sure that they are scaled properly. So the mean should be 0 and the standard deviation should be 1, which is correct. And now let's do the sequential feature selection. So we're gonna make it to 3 hash symbol. We're gonna copy the code here. Creating the SPS feature selection algorithm. And we could develop by the authors of, or we could just say developed by the last name or surname of the first author, et al. And the book is just recently published, so it is 2022. 2022. And then we run the code here. And then we're going to run it here as well. So we will apply the SBS feature selection. And then let's see. Oh, okay, it is a continuous type. Okay, because before it was a for the accuracy, which is the classification. So I guess we'll have to modify the above code here, but then this is outside the scope of this particular tutorial. So I'll leave that as a challenge for those of you who are interested in modifying this code to work for a regression problem. Let's continue further. And let's see, this is the random forest. So we're going to say build a random forest model, fit the data, X train, Y train. Oh, okay. So we have to change this to regressor. This is regressor. And let's copy this. Oh, okay, and then we have to modify this to be the F. Feature label should be like that. Let's see if that's correct. Everything except the last column. Okay, that's correct. Let's see if it works. All right, it works for this particular model. And that was all. Because we only have 4 features, we will skip this and we will just delete this. So you can see here that we've just repurposed the codes mentioned in this particular book into our very own Jupyter Notebook on another data set, which is the solubility data set. And so you can feel free to do the same with another data set of your choice other than the solubility data. And so links to the Machine Learning with PyTorch and Scikit-Learn book will be provided in the video description. And let me know in the comments which data set are you repurposing the code for in your own data science project. And so I'd love to read them all and see how each and every one of you are adapting the contents and code of the book for your own project. Thank you for watching until the end of the video. If you reached this far, please drop a balloon emoji in your comments so that I know who you are. And you can support the channel by subscribing to the channel, smashing the like button, and also hitting on notifications so that you'll be notified of the next video. And as always, the best way to learn data science is to do data science. And please enjoy the journey.